Okay, so right now we're going to talk about growth and decay. So compound interest annual. So um, so when you've got a growth or decay function, your function looks like this: y equals a times b to the x. And when b is greater than 1, we're going to have growth, and when b is less than 1, we have decay. But for this lesson, we're going to be focusing on growth. Okay. So in the previous lesson, we learned about simple interest, which when investing, the interest remains the same for the entire year based on the money that you initially invested. Compound interest, when the interest for each compounding period, as so let's just say it's annual interest. At the end of each year, you use the interest plus the amount in order to get the next percentage. Your interest builds upon not just what you initially put into the account, but um, as it grows, it will grow on the amount that's there, not what you had initially. So let's do some examples. Okay. Before we can even start, we need to talk um, rates. Okay, so so we've got this function here. So let's just say our growth rate is 5%. We need to use a b value of 1.05. Now, why is it 1.05? Basically, this is 100% plus 5%. Okay, so if we convert that to a decimal, it's 1.00 plus 0.05, right? So that's how we get the 1.05. If it's growing 10%, we're going to have this one is from 100%, and this is the 10% growth. If there's no growth at all, b is 1, right? If b is 1, then it never changes, right? So these two examples are ones that I see a lot of students make mistakes in with decimals. If it's growing 0.1%, that means if I move the decimal place 2 over, it's really growing 0.001. You may want to pause and think about that. If I'm growing 0.25%, if we move the decimal place over 2 spaces, we get 0.0025. This type of decimal percentage stuff really is what banks try to fool their customers with if they're not paying much attention to the decimal in the percent. Okay, we're going to use some vocabulary that we need before we get started. So the book is going to use PV, FV, and N, and this is common variables that are used in finance math. So PV stands for the present value. Basically, it's the capital of money that we invest into the bank. FV is future value, and it's the amount of money earned after n years. So this is basically the interest plus the capital. And then N is the number of years invested that the present value is invested. And then we use this formula here, where the future value is equal to your capital or your present value times your rate that you use, and we're using these different kinds of rates. Okay, and then N is the amount of time. You might want to hit pause and copy this down. Okay. So let's do some examples first. Okay, so Peter invests $2,000 into the bank that offers simple interest at 3%. Okay, Paul invests $2,000 in a different bank that has compounded interest annually. Calculate how much money they will earn after 10 years. Okay, so if we're doing simple interest, so for Peter, we're going to be using the simple interest formula, which is C times R times N. So that's going to be equal to 2,000 times 1 point, whoops, no, that we're going to be using 0.03 and then times 10. And then we get and then I get 600. Where'd my pen go? How did I lose my pen? Okay. Okay. For Peter. All right, so let's do Paul in a different color. Okay, so for Paul, it's growing compound. So basically, there we go. The future value is equal to the, let's look at our formula again. So the future value is equal to the present value times our new rate to the power of n. So the future value is equal to, we're investing $2,000 times 1.029. Think about moving that decimal place 2 over, and then we get there. And this is to the power of n, which is to the power of 10. Okay, so let's put that into the calculator. 2,000 times 1.029 to the power of 10. And I get the future value is 2661.85. Okay, so this is the amount after 10 years in the bank. And for here, we need to add what we started off with. So in the bank, we've got 2,000 plus 600 equals. Okay, and so we can tell that Paul is going to be earning more money than Peter. Okay, part 2. Determine after how many years they will have at least 5,000 into the account. Okay, so what I'm going to be doing here is let's work on Peter first. So for Peter, we want to know when he's going to have 5,000. So in order to have 5,000, we know that I has to be 3,000, because if we're starting off with 2,000, we need to grow 3,000 in order to get 5,000, right? So I'm going to say 3,000 equals C, which is the initial value, which is 2,000, times, what's my rate? 0.03, and n, we don't know what n is. We're trying to calculate what n will be. Okay, so So 2,000 times 0.03 gives me 60. So I got 3,000 equals 60 N. And so 3,000 divided by 60, we're going to get 50. So after 50 years, Peter will have $5,000. Okay, now let's calculate for Paul. Okay, for Paul, we want to find out when our final answer is 5,000. So basically what we do is we do, our FV has to be 5,000, so we can say 5,000 equals 2,000, that's the amount we're investing, and our B value is 1.029, and that's to the power of n. We don't know what it's going to be. Okay, so first thing I do is I divide both sides by 2,000, and then I get 2.5 equals 1.029 to the power of n. And we want to find out what power this is going to be in order to get 2.25. Okay, so if I want to convert this to, so let's do this. I could have 1.029 to the power of x, and I'm going to have another one, a line where I just have 2.5. We want to find out when those lines intersect. Okay, so the bottom one, you can see it's curving ever so slightly, and this 2.25 is going across. So let's change the x-axis here. I go to Window, and I'm going to change the x-max to, let's make it a bigger number, 100. The y minimum, let's just make that -1, and the y max doesn't have to be 10. Let's make it 5. Okay, so now I can graph it again. So 2.25 is like right up from there. Okay, so I want to find out where this intersects. So I have to hit second trace, and I'm going to go down to 5, where it says intersect, and okay, so it's got, I'm going to arrow so it's close to it. Right now it's got the exponential function. I hit enter, and oh, I must have hit the wrong thing. Second trace, intersect. I must have hit 6 by accident. Oops. First curve, it's got the exponential one. I hit enter. Second curve, it's got 2.5. I hit enter. Guess, I hit enter. And then I get the intersection is 32.05. Okay. Okay, let me write down the calculator steps that we just did. So what was the first thing we did? We hit y equals, and then I typed in the two equations. y1 equals 1.029 to the power of x, y2 equals 2.5, The next thing I did was I changed the window. And I made x max equal to 100 and y max equal to 5 and y min equal to -1. Okay, then I hit second trace. And I went down to intersect. And then it said first curve. I hit enter. Second curve. I hit enter. And then it said guess. I hit enter. And then I got this answer here. So it's after 32.05 years. Okay. So the buttons I hit were y equals, I entered that in. Second trace, hit the 5, enter, enter, enter. And that's what you need to do your compound interest assignment.